Okay, I'm going to solve the problem 9.45. And approach to do this problem, it's knowing that the acceleration is constant. We can use the kinematic equation to find the speed of the following object, which is this. And then we can apply the work energy expression to the entire system to find the moment of inertia of the wheel. And finally, using its radius, we can find the mass of the wheel, which is the question of the problem. So we're gonna do this step number 1. What do we know? We know the mass of this object is 4.35 kilograms. We know the vertical displacement is 3.15 meters. The time is 2.03. The radius of the wheel is 0.266 meters. And we started with a velocity initial 0. So the first kinematic equation that we're going to use is going to be vertical displacement is equal to initial velocity in the y direction plus final velocity in the y direction divided by 2 times the time. From that, we know this is 0. We can determine that velocity final in the y direction is going to be 2 times the vertical displacement divided by the time. And according to this quantities over here, we have this is 2 times 3.15 over 2.03, which is equal to 3.10 meters per second. This is step number 1. Step number 2 is going to be finding the angular velocity, because we know the angular acceleration of the wheel is related to the linear velocity. We can use this formula. Angular velocity is equal to vertical final velocity over the radius. And according to the quantities over here, we know this is 2 times 3.15 over 2. Let me just erase this. This is equal to 3.10, which is the velocity we just find, over 0.266, which is equal to 11.65 radians per second. Let me erase the board to do the final step. Thank you. On this third step, we're going to apply the work energy equation, which is this one. Initial kinetic energy, initial potential energy, work overs equals to final kinetic energy and final potential energy. So what do we know about the problem? Is frictionless. Is it frictionless? Work done by others is equal to 0. And then initially we don't have any kinetic energy. So we just ended up with potential energy initial equals a kinetic energy final plus potential energy final. Then replace this for the formulas. This is m times g times displacement on y, and this is equal to 1/2 moment of inertia times angular velocity squared plus 1/2 mass times velocity final in the y direction squared. So what are we trying to do is find the moment of inertia, which is this. So, and this is equal to 2 over angular velocity squared times mass times gravity times displacement on y minus 1/2 mass velocity final in the y direction squared. So we have all of these quantities. So this is going to be equal to 2 over 11.65 square times 4.35 times 9.8 times 3.15 minus 1/2 times 4.35 times 3.10 squared. And this is equal to 1.67 kilograms mass square. Then we can use this formula. inertia is equal to 1/2 the mass of the wheel times the radius square. So mass of the wheel is going to be 2 times the moment of inertia over radius square. And this is going to be equal to 47.20 kilograms. That's it. That's the answer of the problem. Thank you.